Amazing. All right, so I guess first of all, thank you very much to the organizers for having me here, for inviting me to this conference. So I'm a senior applied scientist at Zalando, and if anyone of you doesn't know, Zalando is the leading fashion e-commerce company in Europe. And the topic that I want to talk about today is actually very tightly related to like the introductory talk from Darko earlier, which is really like how can you gain trust in like causal AI, causal machine learning models like in practice. Because like often in the business you have to face like non-technical stakeholders or like people that have like are less technical than you, and you need to convince them like to trust like your estimates, your models, and ultimately the decisions that they need to take because of those estimates. So I'm gonna be fairly specific and focus on very specific application that at the very least within Zalando is very common, but I'm pretty sure most practitioners have faced in different industry, in different settings. So the setup is the following. Is like you have some kind of a feature or program that has been released to the whole customer base. And this is crucial, like we're talking about something that already happened, right? I mean, I can make a long story short of what my ultimate recommendation in this setting is, and is like run experiments whenever you can. But in this case, I'm talking about a setting in which like whatever feature or policy was already released, and so you cannot experiment anymore. Like it's already out there. Now, you have, however, only a subset of the population or your customers that use the feature or have enrolled in the program. You also have rich data in the sense that for this, like you have many customers, and for these customers, like you know basically what they've done in the past. You might have like some browsing history, some transactional history. So your data is rich both like in a wide sense in terms of number of customers, but also long in terms of like the time series of these customer actions. And like importantly, what might seem a small detail, you might also have some indicator of whether these customers like are interested in the program, took some actions maybe, tried this feature. So for example, they have entered a funnel, or they have done like a trial period in a subscription program, or something like this. And now like a question that at least myself, but I'm fairly sure a lot of like data scientists have faced in the industry is, so what's the value of this feature, or what's the incrementality of this program, right? Like product manager, like or like product stakeholder comes to you and wants basically you to put up a number on that product or feature. So I'm gonna use like an example here, which is Zalando subscription program, which is called Zalando Plus. In short, is a subscription program in which like you pay an annual fee, and in return you get faster shipping and free in the sense that you don't have anymore to have a minimum order value, plus some other benefits as well. The program is already live in 7 countries, actually for a while, and importantly, we also until recently had a short free trial. Now. What do we want to measure in this setting, right? So the main thing that we want to measure, often at least, is just the overall impact of the program, or technically speaking, like the average treatment effect on the treated. So the counterfactual question of interest is, like, for these customers, what would have happened if they had not subscribed to the program, or like in other settings, like if they have not used the feature, right, or they have not tried a particular like feature or policy that you have in your platform or business. So the good thing here is that the counterfactual outcome is pretty well specified, right? It's really about constructing this counterfactual world in which your subscribed customers had not subscribed. this is more of a backward-looking question, right? Another question that like often appears in the settings is what is the impact on different customers, right? And usually this question is relevant for some kind of policy targeting. For example, again, coming back to the Plus subscription program, like you want to understand, like, do we want to like stimulate some customers, like incentivize them to subscribe to the program, right? What are our best customers to try to make them roll? Do we want, for example, to offer some customers a discount? Do we want to target some customer with advertisement? This is a little bit of a more complicated object, and for the rest of the talk, I'm mostly gonna talk and focus on the first one. Now, the second thing is more practical. It's like how do we measure like the impact of the program, and in particular, like what is the treatment in this case, right? So I mean, of course, it's very easy or like relatively easy for treated customers, especially with a subscription program. For example, you may want to measure what happened in the first year after they subscribe, right? So what's the value that in the first year they generate for the company? And usually what you want to build or try to estimate is like comparable control group to compare against these customers that have actually subscribed to the program. And now the tricky questions are often, I mean, of course, which customers to bunch together in the analysis. For example, because you can imagine that if you have an open subscription program, you may have different kind of selections, like if a program is like newly released versus a mature program, you can, for example, expect customers that like would have benefit and would have interested in the program the most to subscribe first with respect to later subscribers, and maybe you don't want to bunch them all together in a single analysis. Another very tricky question is if you want to compare these customers to some other customers that did not subscribe, like what's a treatment event, right? Like if you use a certain time window over which to measure outcomes, where does this window start for customers that did not subscribe? So in our case, like it's really clear that this window for subscribers starts when they subscribe, but for non-subscribers, what's a comparable event? Like it's definitely like a visit on the website, right? Since to subscribe, you have to visit the website or the app. But like, is it comparable to making an order, right? Most customers place an order at the beginning of their subscription or trial period, but not all of them. So this is another kind of tricky questions. But I think in the end, most importantly, there's a question of which method to use. And I like to think of like two general types of methods to answer this question. So the first one is what I call double ML or similar. I guess this is the name that is like most frequently like circulating in the industry at the moment. But in the end, what really means is that you're relying on these assumptions that I know with the name of unconfoundedness, but different people might know with different names. And like in practice, in words, simplifying a little bit means that we assume that we're able to find some comparable customers that did not subscribe to the program or did not try the feature, right? So this assumption might be more realistic in case the number of people that did not subscribe to the program is particularly large, right? And your data is particularly rich, and so you might be very confident that you're able to find customers that basically look exactly as subscribed customers, except for the fact that they subscribe. There's another path though, and the other path is like the difference in differences path, but more generally the path in which you say, okay, like these two customer groups are different, and they're different, like basically we're unable to find these comparable customers, right? And we accept that there are these differences. But what we assume here is that these differences are some kind of stable over time, or at least predictable over time, right? We are able to understand and know like these differences. And there might be some data-driven ways to guide you a little bit in the choice of method that you apply here, right? For example, like and on the left, I plot the revenue per order over customers, and even if you have a very small portion of treated customers that probably like are more frequent orders, like in Zalando Plus, of course, the more orders you place, like the more the subscription program is beneficial to you. And maybe, so even if those customers are on average more active, maybe you have such a big pool of customers that did not subscribe that you have good chances of finding comparable customer. But the other option instead is, of course, like the main assumption between differences, if you ever use or like studied it, is that basically this customer trends before treatment, at least on average, follow some parallel trends, right? So the idea is, again, that you have some difference, but it's predictable, right? On the other hand, in practice, trends like are really never parallel, so it's a matter of like how much I trust like these trends to be stable over time, or whatever model you use to be able to understand the differences also in the future after treatment. In practice, however, I think what the step that requires the most amount of attention and has definitely helped the most in setting up this type of analysis, but also helping other people in understanding how to set up the same analysis in other settings, is thinking about selection, right? Because these are all like settings in which some customers, for some reason, decided to subscribe or to use the feature, right? And so, of course, if for some reasons these customers decided to subscribe to Zalando Plus because they just have a kid, for example, and from one day to the other, they know they will need way more orders, right? They have one more member in the family, and there's no way that in your transaction or on-site data you can find out some early signals of this shock, then there's no way out. Like, there's nothing you can do, right? If this selection is based on some shock that happens out of nowhere, that is unpredictable, then neither method will help you, and actually no observational method would help you. On the other hand, if customers, for example, that order a lot, right, find the program useful for them and therefore decide to subscribe, this is basically a signal that, maybe some customers are more or less aware, and so just looking at their order frequency before the program was rolled out, you might be able to find some comparable customers. On the other hand, it may be that some customers just need, for some reason today, faster shipping, right? You have one order, I don't know, you wanna you buy a gift for a friend for their birthday and you need it fast, and then you have a look at the subscription program and you're like, okay, actually it pays off in a couple of orders. I need it today, but maybe in the next year I will still need it a couple more times. It might be worth to subscribe today. Then basically you have some signal that tells you what could have prompted these customers to subscribe. And the signal often materializes in this kind of early funnel, early access type of features you want to look at and understand which customers are interested, which customers are not. Now, very quickly, I want to go through, I have listed a set of tests or checks that I found useful, that I think one can do, not to test the assumptions of the model you're using, but just to gain a little bit of confidence in what you're doing, right? And the first check is just to visualize estimates. It seems pretty trivial, but especially for dimensions that basically you have not fit your model on, right? For example, you fit the model on aggregate pre-treatment data, and then you plot like a very granular time series. Seeing that this like pre-treatment time series aligned really well across treatment and control group might be a good indicator that your model works. Or actually, I would say if this does not happen, is like a pretty alarming red flag that your model might not work, but might also point out to certain feature that you might want to add to your model. For example, you're not able to match certain periods of time, certain shocks, or certain patterns. The second thing that I saw many people using also in other companies is to do what I call pre-treatment placebo test. So basically whatever you're doing around the treatment date, so like before and after the subscription to the program, just repeat it but before the treatment. So keep the same population of customers that subscribed and did not. And in principle, if indeed you're using like a double ML model, so trying to generally find similar customers in the control population, you should be able basically to obtain a pretty precise null effect if you shift your whole analysis before treatment. And importantly, this is also relevant when estimating conditional average treatment effect, because in principle you know that not only your average effect should be zero, but also any heterogeneous effect that you are estimated should be zero as well. It's also I think if any of you heard of conformal prediction, like it's this kind of type of analysis that you can a little bit of confidence on your model inference by looking at how they perform in a similar setting in which you know what should be the output. The third thing is just to look at effect boundaries. So this is really grounded in your particular business case, but there's often the case that you can exclude certain effects. Like you can put on some domain knowledge, so you can either use it directly in your model, but if you haven't used it directly, you can use it as a test, right? Like for example, if you assume that people that subscribe to Plus are usually people that are more active, right? Then you can say that there's a positive selection bias, and so if anyway, you can assume that whatever estimate you're getting out of your model is probably an upper bound of the true effect. The third thing here is actually a bit of a ladder of complexity. And I think it really closely aligned to what Darko was saying in the introduction. Like if you want to gain confidence in what you're doing, it's extremely important that you proceed in a step-by-step manner, like from very simple baseline estimates, adding complexity one step at a time. And especially for what concerns reporting, right? Start from simple difference in mean, so whatever control group you have picked, or whatever prediction model you have built to predict the counterfactual outcome from a treated group. Start from a very simple difference in means and add one piece at a time, and especially enable stakeholder to see how your estimate evolves from basically the raw data to your final outcome. And at last, and a little bit more technical, there's I put here one, but there's a set of more technical sensitivity checks that you can do. They are often model specific. Very importantly, they usually are not checks on your assumptions. They are more again, some tests that give you a little bit of confidence, that your model is working correctly, or in case it doesn't, put a little bit of bounds to the errors that you might be making. So to conclude, going forward, what we've been developing recently is a set of guidelines for this kind of situations within the company, in which, again, we don't give recommendations on the type of tool that we use, but we basically give a sequence of questions and checks that we recommend like data scientists and analysts to perform in order, first of all, to understand their problem. So as I said before, for example, understanding how the selection process works, and really like making sure people have spent enough time thinking about it. Then second, a very important thing is that while like there's always a component in this model, there is just a pure predictive component, right? It's just one part of the problem, right? Like of the solution is not the solution. But for example, for these models, like they're often reusable across different settings, right? So for example, if your outcomes are like, I don't know, order per customers, like having like a centralized, fine-tuned, trustable like model that predicts order per customers is very important, and especially like it's reusable across different situations. And small note, also in experimental settings when you want to understand heterogeneous treatment effects. And last, what I've been working on recently, more as like a side research project, is trying to validate this kind of models in setups in which you have some experimental evidence to try to understand against some experimental evidence how well this model performs. I guess that's it. Thank you very much.
Thank you, Matteo. There are a couple of questions, if you're okay for those.
Yes, please.
Yeah, okay. There's a couple more technical ones, but we'll do those as well. What options did you have for identifying treatments? Or was it based on impressions?
I guess identifying treatments here means like what are potential like treatments for the control group. Sorry if I misunderstood the question. I think again it boils down to domain knowledge. So really trying to understand like what were the customers doing when they subscribed in the case of Zalando Plus, or where they use the feature in other settings. And what kind of signals, right, the company has, like which kind of data do we have to understand exactly what the customer was doing in that setting.
Excellent, thank you. There's more coming in, but we'll try and keep on top. If you want to estimate the incremental effect of a specific cohort after 3 months, how do you take time dependence into account in the double ML method?
Of a specific?
Of a specific cohort group, so specific group that you're looking at.
Yeah, I mean, I guess there's a lot of different approaches. What I found like a fairly simple but useful approach is just to split your population into segment on time periods. So it really depends on your setting, but like, I don't know, do like a monthly, quarterly, or yearly cohorts. It's really like about like how much you think like selection changes over time and your customer base changes over time. There's often also like data constraints, like if you have like a very small sample sizes, maybe you can digest everything at once, but sometimes like also for practical reasons you need to segment.
Excellent. I know we're close to time, but I'm going to squeeze one more question in, which is, have you used your models to make any changes to your business decisions? Are there any examples you can share?
Yep. I mean, I'm gonna talk very high level. Like this kind of situations, as I said earlier, like there's two main questions that you wanna answer. The first is just policy evaluation. So like, is this program or feature actually profitable, right? And the decision that often like a bit indirectly sometimes come out of it is like budget allocation within the company, right? So like a specific team or area of the company, like requiring more or less resources depending on the number that comes out of it. And the second thing is instead more policy targeting, looking forward. So for example, in the case of the Plus subscription program, we were looking, as I said, like how do we incentivize different customers to join the program? For which customers do we want to promote the program, right? Which customers do we want exactly to prioritize within the program? These are the type of questions that you can answer.
Perfect answer. Nice way to wrap up. Thank you, Matteo.
Thank you very much.